Hello, welcome to Physics World. Our day starts with observing different things outside, like walking of a boy, a student running on the road, a moving car, a moving auto, a moving truck, etc. If you watch movies and TV channels, you can observe that motion of a satellite, motion of a rocket, motion of planets around the sun, especially our planet Earth around the sun. If you observe all these types of examples, you can observe that all these are not the same type of motion. There are different types of motions. So why do you have different types of motions? Or at least we should know that what type of motions generally we observe daily most of the times. So to explore these things, let us start the chapter called motion. Let me write the types of motion. A moving car, it is linear motion, and a moving bus on the road, what type of motion? Yes, you are correct. It is again linear motion. At rotating around the sun, what type of motion? Yes, it is circular motion. Okay, you watch cricket many times. Yes, so then see, a batsman hits the ball. Batsman hits the ball. What type of motion of the ball? Yes, it is curved motion. Right. Now, a football player hits the ball, or a football player kicks the ball. Then what is the path of the ball? Football. Kicked by a football player. What is the path of the ball? Yeah, maybe this type of, yes, of course you are correct. It is curved motion, but specifically it is called projectile motion. A spring is stretched and released. Then what happened to spring? The spring will move back and forth. Motion of a spring. What type of motion it is? Yes, it is called vibratory, or you can say oscillatory. There is a slight difference between vibratory and oscillatory, but here we don't discuss the difference. But vibratory or oscillatory is nothing but back and forth motion, or you can say to and fro motion, like motion of a pendulum. So once you check all these examples, you get to know that we are not having one type of motion. We have linear motion, circular motion, curved motion, projectile motion, vibratory or oscillatory motions, etc. Different types of motions we have. But in this chapter, our focus is on linear motion. Before discussing about what is linear motion, let us understand about the difference between rest and motion. See the diagrams here. A person P, a person Q. This person P is at the location O, or at the position O, at time t equal to 0. Now, the time is increasing, 2 seconds, and then after 4 seconds, and after 6 seconds. Even though the time is increasing, the person P still at the same location O. Then we say that the person is at rest state. Now see the person Q. The person Q at O at time t equal to 0. After 2 seconds, he is at A. After 4 seconds, he is at B. After 6 seconds, he is at C. So when the time is passing, he is changing his position. The position is changing. Then we say that this person is in motion. So the difference between rest and motion is, rest means if any body doesn't change its location with respect to time, then it's called rest. Let me write here. Body does not change its location with time, then it is rest. Now, motion. Body changes its location with time. Then we say the body is in motion. So it is rest and this is motion. Now tell me, after watching this part of some of this video, you need to know that what type of state you are in. You are in rest state or you are in motion state. Think. My question is, yes, you are watching the different type of things outside and you are also believing that motion of a car, motion of a truck, or the walking, running is exactly a motion. Yes, I agree with you too. But motion is relative. That means if something is moving with respect to one person, the same thing need not to be in motion with respect to the other person. Let me explain. See this diagram carefully. It's a bus moving on the road is in motion. In the bus there are many passengers. I have located 2 passengers, passenger A and passenger B. And there is an observer on the roadside who is watching the motion of the bus. Now, according to the observer O, what is the state of the passenger A? Obviously, as the bus is in motion, in the bus everything should be in motion. So, according to O or according to observer, according to O or the observer, passenger A, yes, is in motion. Passenger A is in motion. Passenger A in motion. According to observer O, passenger B is also in motion because these 2 passengers in the same bus. Now, according to B, what is the state of the passenger A? Just think when you are traveling in your school bus, sitting next to your friend. What is the state of your friend who is sitting next to you? Yes, you are correct. Rest state. Yes. So according to B, the passenger A is at rest. See, I have taken the same passenger A in the 2 cases. In one case, according to observer O, he is in motion. In another case, according to B, he is in rest. That means motion is not exactly motion in all the time with all observers. For some observer, maybe the motion is in motion. For some observer, the motion is not motion, it is at rest state. So that's why motion is relative. A body, for somebody, it is in motion. But it need not be in motion for some other reference or some other body. So that's how we can say that motion is relative. One more example I will give you. Earth is rotating around the sun. So Earth is in motion and we are staying on the earth. We are standing on the earth. We are living on the earth. What is the state of us? Do you think that we are also moving? No. At this moment, you are watching my video. You're at rest state. When this video is taken, I am also at a rest state. But Earth is rotating. So according to us, the people standing next to us are a rest state. But the same people are observed if they observed from other planet, say Mars planet. Now what do you feel? Yes, you are correct. As the Earth is rotating, the person standing on the or living on the Earth are also moving. They are in motion. So according to us, the persons next to us are in rest state, but according to Mars, they are in motion. That's where motion is relative.